Assalamu alaikum students. The question we are starting is question number 9 from exercise 10C of T4. Here you can see in this figure that we have two triangles. Alright, the triangle ACD, right, this one, and another triangle ABC. And both of these triangles are right angled triangles, which means one of the angle is 90 degree in both of these. You're given the values of some sides and some angles, and in part 1 it is required that you find major angle ACD. In triangle ACD, the major angle ACD, which would be this angle here, this one. This is we are asked to find. So let's begin. First of all, you need to understand that in a right angle triangle, the side opposite to the right angle is hypotenuse, right? For this triangle, we are finding it for triangle ACD, right? And the side which contains the angle that we are finding and the right angle is called base or adjacent, whatever you want to name it, right? And then the other side that is remaining is called perpendicular, which I'm denoting by the symbol of perpendicular, right? So here I can see that if I apply the trigonometric ratio of tan theta, it is equals to perpendicular over base. I know the value of perpendicular, I know the value of base, so I can find this angle. So let's start. First part is angle ACD. So I'm applying tan theta is equals to perpendicular over base. I know the value of perpendicular, that is 4.8, right? Over base is 7.6. So theta will be equals to which is angle ACD, or I can alternatively write it as tan angle ACD. It will be correct both ways, but just to remember that this is the angle that we are finding. So here I can also write that angle ACD is equals to tan inverse to 4.8 over 7.6. Now on finding the value of both these values, you will get ACD equals to 32.3 degree. So we have just done with this part. The next thing is to find the value of AC in this triangle, which we can easily find by using the triangle ACD, because I know the value of two sides, and by Pythagoras theorem you can easily find the other side if you know the value of two sides, and that is applicable only in case of a right angle triangle. So to find AC using Pythagoras theorem, and on which triangle I'm applying on it, on triangle ACD, right? So we know that it says that hypotenuse square is equals to base square plus perpendicular square, right? Hypotenuse is this side AC, which we are trying to find, and base is 7.6 square plus 4.8 square, right? And on solving you will get AC equals to, it comes out to be 8.99 centimeter, right? The next thing is to find AB, which is the side of triangle ACB. Now what we know in triangle ACB, we know the value of this angle, we know the value of this side, right? We know the value of AC, which is 8.99, right? And we need to find this side. So if I apply, I need to find AB, and I apply the value of the formula of cos theta, which is equals to the trigonometric ratio cos theta is equals to base over hypotenuse. So I know the value of this angle here, only this one, right? Besides this 90-degree angle. So I'm taking this angle. So I will write here that cos of 54.6 is equals to base, which is in this case of course AC, which contains both angles, right? So I write here 8.99 over hypotenuse, which is of course the side opposite to this 90-degree angle, the side AB. And that's what we need to find. So I'm going to rearrange this equation. AB will be on the opposite side by cross multiplying, and cos 54.6 will be divided on this side. So AB is equals to 8.99 over cos 54.6, right? And on solving you get the value of AB equals to it comes out to be 15.5 centimeter. Now look at the part B of this same question. It is given that E is a point on AB such that AE is equals to 7 centimeter. We don't have a point E in this figure, but they have told us that E is a point on AB, right? There is a point E on AB such that AE is 7 centimeter. That if I take that point E over anywhere, let's say this is the point AE, then it will be equals to 7 centimeter. It's given in the question. Find the area of triangle ACE. Area of triangle ACE. We know the point AC and this is point A. So we can draw this triangle. ACE will be this triangle. That would we get by joining these 3 points, right? So we need to find the area of this triangle. It's not a right angle triangle, so we know that the formula for it would be area of this triangle. ACE will be equals to half AB into sine angle C. We can take here AB are the values of any two sides as AE, it can be AE or AC, right? So we will take the values, we know the value of two sides, and the angle that we use here is always the angle that is formed between those two sides that we are using. Like here we are using AC and AE, and we know the value of the angle that is formed in between these two sides, right? So I'm gonna find the area by using this formula. Half one side is 7 centimeters, so I'm gonna write it here. This other one AC is 8.99 into sine of angle 54.6, right? And on solving this whole values, simplifying, you will get 25.6 centimeters square. So that's all we need to find for this question. Thank you.